Hello, everybody, and thank you for joining me today. My name is Tom Ebeyer, co-founder of the Aphantasia Network. And with me today, I have Paolo Bartolomeo from the Paris Brain Institute, who's here to talk about mental imagery and all the great work that they're doing there in Paris. So without any further ado, Paolo, thank you for joining me today.
Hello, thanks for having me.
Well, for everyone who's joining us live, you can feel free to ask questions in the live chat there, and we will get to them at the end of the discussion. And in the meantime, let's get started. Paolo, I'd love to hear a little bit, about you and your background and how you got into, interested in mental imagery.
Yes, so I'm a neurologist by training, and I studied in Rome. And at that time, yes, more than 30 years ago, actually, during my residency in neurology in Rome, I studied representational or imaginal neglect. So these are patients, usually with right hemisphere strokes, who do not pay attention to what happens on the left of their space. So they bump into objects on the left. They don't eat from the left part of their plate or something like that, things like that. And some of these patients actually do not pay attention to the left part of their mental images. So if you ask some of them, not all of them, if you ask them to describe from memory a well-known place, the first description was from whereas to describe the Piazza del Duomo, the square of the cathedral in Milan, which is very well known by all Milanese people, and they forgot to mention all the left-sided details from memory. So the conclusion at the time was that neglect was the loss of the left part of a mental representation of space. Now in Rome, I was able to show with my coworkers by asking Roman patients to describe Roman piazzas that actually this couldn't be the case, because only a minority of patients with visual spatial neglect also have neglect in their visual mental imagery, only about a third of them. So it cannot be the explanation of visual spatial neglect. But the phenomenon remains in a minority of patients, and it still defies at least our explanations. We still don't know why exactly some patients lose the possibility to describe the left part of their mental images.
And these would have been things that they were familiar with before
Yes.
the injury or the stroke that caused this difference. Yes. And so those images, those memories should still, be intact.
Yes. And this is shown by the control experiment that was performed in Milan, for example, because the researchers in Milan, they asked to describe the same place, the Piazza del Duomo, but from the opposite perspective. So patients had to imagine, for example, to exit the cathedral and to describe the piazza, and then they described what they now imagine to see on the right side, which was before on their left side, and it was not described. But now the mere change in perspective was enough to enable this patient to describe what they described before. But now they forgot to describe what they had described before, the former right part, which was now the left part of their mental image.
So it shows that the information, the memory is still, present,
Exactly.
but not perceptible.
There, but it is not accessed in a fashion to permit the explicit, at least, description.
Very, very fascinating series of cases. How did you then get from Rome to your work now at the Paris Brain Institute? What do you do there?
Yes, at the end of my PhD in Rome, there was an international European fellowship available, and my mentor proposed it to me to come to Paris. And I came to Paris exactly 30 years ago now, and here I am. Then in Paris, I saw another fascinating neurological patient who also sparked my interest in visual mental imagery. And she was a patient who had the misfortune of having two strokes in almost symmetrical parts of the brain, in the lower part of the brain, along the visual, let's say, the pathways between early vision and high-level vision, between the occipital and the temporal lobe of the brain. And this patient, of course, had enormous visual problems. She couldn't recognize objects. She had agnosia. She couldn't recognize colors. She had achromatopsia. She saw the world in shades of gray because of these lesions. She couldn't recognize people. She had what we call prosopagnosia. She couldn't recognize people by their face visually, and she couldn't read anymore. She had alexia. But despite all these deficits, she had perfectly preserved visual mental imagery for these same items. So if I ask, she couldn't see cherries and strawberries, at least the color of cherries and strawberries. But when I asked her which red is darker between cherries and strawberries, she could very well picture cherries and strawberry, visualize cherries and strawberries in her head. She told me so that she could see very clearly in her mind cherries and strawberries, and she was perfectly able to answer this kind of questions. And this was the first time I doubted the dominant model of visual mental imagery, which is, even now, it is probably the dominant model, which says that to visualize things, you need to use your primary visual cortex. This cannot be true because in this patient, we know that her primary visual cortex was disconnected from more anterior stages of processing, so that she could not recognize by sight objects or faces and so on. But her visual mental imagery was perfect. So she must have used different brain structures than the primary visual cortex to visualize her mental images.
And this goes to that core mental imagery debate. I think it's been going on for kind of a long time. Do you mind, for those new to the subject, kind of summarizing what is the mental imagery debate and how this case kind of plays into it?
Historically, it was mainly the debate between Stephen Kosslyn, psychologist. Now he's retired, but he was an eminent psychologist at Harvard University, who said that mental images are built in the brain exactly like real visual images, starting from V1. Actually, V1 is the primary visual cortex. And actually, it is this quasi-visual processing which gives visual mental images their visual character. On the other hand, there was this other psychologist, Zenon Pilishin, who said that, actually everything in the brain is symbolic, it's not pictorial. So that there must be some propositional, symbolic, non-pictorial code, which is at the basis of visual mental images, as it is at the basis of language, of memory, and of every other cognitive process. This was the big debate during the last century. Then there was some neuroimaging evidence suggesting a role for primary visual cortex or visual cortex in general in visual mental imagery, which went more towards the Koslin's model. However, as I said before, the patient I studied and many other patients, actually, neurological patients in the literature provide causal evidence that this cannot be true, at least in a literal way. And here in Paris, we performed first a meta-analysis of all fMRI studies, all neuroimaging studies, which had been done on visual mental imagery. And then we performed our own visual mental imagery fMRI study by using ultra high field fMRI, 70 fMRI, so a technique with unmatched resolution to visualize the living human brain. And we saw that actually early visual cortex is not used at all during this kind of tests, the tests of visual mental imagery. This does not mean that Pilishin was completely right in saying that there is nothing visual in visual mental imagery, because we did see high-level visual regions, more anterior in the temporal lobe, the floor of the brain, let's say, in the anterior part, which were activated by this kind of questions, which red is darker between strawberries and cherries, or questions in general about the physical, the visual appearance of objects. So there is something visual, but it is not early vision. It is high-level, late vision, which is implicated in visual mental imagery.
It's very interesting, and questions like this, which is a deeper shade of red, the cherry or the strawberry. There's similar questions like what's a deeper shade of green, the blade of grass or the evergreen tree. Aphantasics can answer these questions, in a quite straightforward way. We had a little, we met in Paris I think in November, and I was speaking with some of your colleagues there. We had a little bit of a discussion about how are these types of questions answered. And for some of the visualizers we were speaking to, they talked about how first they visualize the image and then they choose which one is the deeper shade.
Yes.
But for us, with no image, no conscious image at least, it's not. It doesn't seem like it's a comparison. It's more like an inherent knowledge. And so, how do we square these things, and how does this fit into our understanding of how visualization occurs in the brain?
You're absolutely right. It's a great question, and it remains a mystery for the moment. We don't know exactly. One thing that we were actually surprised to find that people with aphantasia could answer easily this kind of questions. And this is a big difference between, let's say, congenital aphantasia and neurological aphantasia, because there are patients also with lesions more anterior in the temporal lobe who can lose their abilities of visual mental imagery as a consequence of their stroke, especially in the left temporal lobe. And these patients, they claim not to be able to visualize things anymore since their strokes. But they cannot answer this kind of questions. They do not know. And so this is a very important difference between congenital, I would say, aphantasia, which is not a disease, absolutely. It's just a normal variation, probably, a variation in the normal functioning of the brain, and lesion and neurological aphantasia, lesion-based aphantasia, where there is a clear deficit.
And so this gets to sort of the next question then, is something like neurological aphantasia. This is based on some damage in the brain, would cases like this we'd see more as something that maybe needs to be cured or needs to be fixed because they haven't? And is this because there's brain damage, or is it because maybe they haven't learned the strategies or the techniques that a congenital case will have learned? Why are there such differences in these two cases? Is it like the nurture and the adaptability, or is it something else going on?
I don't know what. No, unfortunately, I don't know the answer, a precise answer to this question. This is what we are trying to work about here in Paris and elsewhere in other labs as well. One important thing that we found is that when we put aphantasic individuals in the 70 fMRI machine, while they were trying to visualize or trying to answer this kind of questions on the visual appearance of objects, we saw exactly, or more or less exactly, the same brain network being activated as in typical imagers. The only difference we saw was in the coordination between activation patterns. There is a kind of analysis we do in fMRI, which is called functional connectivity, which is simply trying to assess the temporal patterns of activation of different regions to see whether they activate together or they deactivate together. And what we saw is that in typical imagers, frontoparietal networks high in the brain, which are important for working memory and for attention, they tend to activate together. Their activation is temporally correlated with the activation of these high-level visual areas in the floor of the brain, especially left temporal cortex. In aphantasic individuals, we saw the same activations, frontoparietal plus temporal on the floor of the brain, but they were apparently not correlated temporally, as if, I don't know actually how to interpret this, but it was very clear as a result. As if perhaps one possibility is that aphantasic individuals use less efficiently perhaps their attentional network to read out activity in high-level visual cortex, so that this activity, it is there, it can access information, but it doesn't reach a conscious level of processing. So this is a possibility, but we don't know yet whether it's true or not.
And how would this? This is you think a very different case from the imaginal neglect type of cases where they don't experience half of the image?
Well, it could have some analogies in the sense that we tend to think we don't have a mechanistic explanation of imaginal neglect yet. It's still a mystery, but a possibility could be that these patients who have lesions in these attentional networks in the right hemisphere, frontoparietal lesions in the right hemisphere, perhaps they cannot access information about the left part of their visual mental images. Once again, information is there, because if you reverse the perspective, then they can recover it, but they cannot access it from a determined perspective. So it could
does it always seem to be on that one side of the experience, like on the one side of their perceptual experience?
In imaginal neglect, it's always on one side. And curiously, it seems to be always the left side after right hemisphere damage. You can have a few cases. So neglect is visospatial neglect is especially frequent and severe for the left space after right hemisphere damage. But in a few cases, about 10% of patients with the left hemisphere damage, you can find signs of right-sided neglect. Now, there are virtually no cases of representational of imaginal neglect after left brain damage. For some reasons, which we don't know yet, imaginal neglect seems to be always for the after right hemisphere damage and for the left part of imagined space.
Have you ever come across congenital cases of imaginal neglect, or is it always based on some kind of damage or lesion?
No, no. I must say it's a relatively rare condition. It's not very easy to study. Something I've always thought, but I was never able to test this hypothesis empirically, is that perhaps people with less vivid mental images, or people with aphantasia, for example, they would be less liable to show signs of imaginal neglect. Why do I say that? Because we know, at least for visuospatial neglect, the saliency of right-sided stimuli, or non-neglected stimuli, is important in capturing patients' attention and making them unable to redirect attention towards the left. There is this effect which is very strong in visuospatial neglect. Perhaps there is something like that for imaginal neglect as well, where right-sided visual mental images are able to capture the patient's attention so that the patient cannot go towards the left side of the visual mental images. Of course, if such mechanisms are at work, they would work only with very vivid mental images capable to capture patients' attention. But once again, this is pure speculation. We don't know exactly what happens.
Lots of very interesting questions still in the mental imagery sphere. Based on everything that we know so far about aphantasia and how it's represented in the brain, do you believe it's theoretically possible for aphantasics to experience imagery? We know that the same brain regions are active but not coordinating in the same way. Is it possible to change how those patterns coordinate?
So if it is a functional connectivity problem, then theoretically it is possible to influence brain connectivity. There are many methods, TMS, transcranial magnetic stimulation, non-invasive brain stimulation, or even drugs. They could influence brain connectivity. So in principle, or perhaps another funny way could be to use neurofeedback. So to try to influence, neurofeedback is when you try to influence your own brain activity based on a feedback. So for example, we can record your electrical activity in the brain, or even in fMRI, we can see the activity in the brain and give you some feedback, a bar which goes up or down, for example, some visual feedback according to the modifications of your activity. And in that way, you could be able to change your brain activity by following the bar, by trying to do something, whatever it is in your mind, which makes the bar going up. So this could be theoretically something which can be tried with aphantasic individuals. For example, trying to increase the connectivity, the functional connectivity, the temporal correlation between frontoparietal activation and activity lower in the brain, and see whether this can perhaps bring some mental images to consciousness.
Very interesting. One of the things that we know is that it's not either, aphantasia or visualization. It seems there's a spectrum of experience. Some people experience imagery very vividly, almost lifelike. Other people report very dim, maybe they just see a little image. Why such variation in this kind of experience?
probably it's a spectrum like most human activities and human cognitive abilities. Virtually everything we do or we think, we can imagine a Gaussian distribution with an average, the center, and then an average which is probably most frequent, the most frequent situation, and then situations at the extremes which are less frequent. And this is a general law, I would say general law of nature, not only of human cognition, but probably it's true for human cognition as well.
And do we think something similar would be across all of the senses? Because we've been focused on visual mental imagery, but people do experience sensory imagination in auditory, gustatory, tactile, all of the kind of human senses.
I think.
Do we know much about this?
Guys in your networks, you should be able to answer this question better than me, because no, really, there are some studies. I have no personal experience with this kind of studies, but I've seen some studies, also personal descriptions of people saying, yes, I am aphantasic across all sensory modalities. I don't know whether this is your case or not, for example.
Yeah, it is.
Others say, no, I cannot visualize, but I can imagine sounds very well. So probably it's not a homogeneous situation. But
and
I would
that
to see really real epidemiological, well, epidemiology is not a good term because it's not a disease, but large-scale studies trying to better define this situation.
Because would this imply that there are maybe domain-specific and then more general kind of aspects of this sensory imagination? If some people can maybe not see visual mental imagery, but they can experience auditory, and then others have it across all of the senses, there are differences between domain and general.
This is certainly possible. And this also suggested, shifting to the neurological forms of aphantasia, there have been so-called dissociation described in the literature of patients who could not imagine, for example, we actually described one of such cases of a patient who became, after a stroke, unable to imagine the visual form of letters and words, but he could very well imagine all the other things, faces, colors, spatial relationships, and so on, the shape of objects. So there can be, at least in the neurological population, dissociation even for specific domains of visual mental imagery. This is why okay.
I'm sorry, go ahead, continue.
Now, this is why we try to study, for the moment, 5 different domains of visual mental imagery, which are faces, colors, shapes of objects, letters, and spatial relationships, because these 5 domains have been described as being dissociable in neurological patients, but probably there are more. For example, imagery of movement could be also a different domain.
And so even for those who visualize, there can be individual differences in different categories of visual mental imagery.
In principle, yes.
So one of the,
in principle, yes. I don't know whether it has been studied in non-neurological populations. I don't think so. In our subjects, but we have a limited sample, of course, they were all at the more or less the same level, these 5 domains, same level of performance and of brain activations.
Across all of them. Where do you see the field evolving? What are some of the big questions in visual mental imagery, and how does aphantasia maybe assist in our understanding of what's happening, how visual mental imagery kind of arises?
So one of the big debates, big issues now in neuroscience is the brain basis of consciousness, conscious experience. And I think with aphantasia, we are exactly there in the sense that, two individuals with the more or less same performance, same cognitive performance, they have very different subjective experiences. How is that possible? To me, this remains the big question of aphantasia in general, and perhaps aphantasia could be a window to understand why we all have different subjective experiences, and perhaps how to modulate them.
Yeah, two very interesting points. One, again, is on the performance, because we do see maybe for some of those aphantasics, just learning about this for themselves, we actually do see very similar performance in tasks that you would assume or previously assumed required visualization. Aphantasics seem to have similar outcomes. But we did see, and we were talking a little bit about this before the interview started, a difference in the confidence of answers that, in this kind of domain. Do we want to maybe explain a little bit about how we found this?
This was totally unexpected to us. But so when my student Zhanghao Liu performed a relatively large online experiment using our visual mental imagery battery in this, so questions about visual appearance of objects in these 5 domains. So people self-describing as aphantasics, first they were perfect in their performance. They were just a bit slower than, let's say, typical imagers in answering these questions. And then when we showed them the corresponding visual items, so the strawberry and the cherry for the color question, or and asked them the same questions, so that, of course, performance is always at ceiling, because it's self-evident that at least in the figures that we showed, very, very simple task, that cherries were darker than strawberries. However, when we asked for the confidence in their response, aphantasic individuals, for this perceptual task, once again, it's not visual mental imaging, they were a bit less confident in their response, in the accuracy of their responses, than typical imagers. We absolutely don't know why. Probably this goes as well also with the fact that they were a bit slower in the visual mental imagery questions. Usually when you are confident, you are faster in answering this kind of questions. So perhaps we didn't check confidence for the visual mental imagery questions, but the slowing on response times could be in this sense. But once again, this is one of the mysteries we'd like to address with the future research. Does this lack of confidence depend on perhaps on less coordination between the systems, the attentional system and the perceptual system? We don't know. Very
interesting, especially because this was based on perception. So they saw the cherry and the strawberry, and then so this is very interesting. One of the and one of the things on the response time, one of the things I think a lot about is this idea that a picture is worth 1,000 words. So if you can very quickly experience an image, there's lots of data encoded in an image. If you don't have the image, at least from my perspective, it's a verbal process. It has to be articulated. This just takes more time to spell something out, to reason it out loud than I would imagine seeing a quick image. So some very interesting phenomenons going on here. we have lots of questions coming in, so I think maybe we'll start going through a couple of the questions, and then we'll kind of branch off from there. But it's been a really great discussion, and some very interesting things, especially around the relationship to consciousness. This is a very, I think, fascinating topic for me because, indeed, the aphantasia really speaks to the conscious experience that people live every day. They go most of just this week, I had someone 92 email me, just discovered they have aphantasia, went their whole life, not knowing that everyone around them was visualizing, and at the age of 92 learns that their conscious experience is, very different from everyone around them. But they went their whole life not knowing that there are differences in these conscious experiences. And, this is like so fascinating that we can go so long not knowing that there is such a fundamental or fundamental is maybe the wrong word, tangible difference. I think this is one of the things about aphantasia and mental imagery that's so fascinating is I think for people it feels more tangible than personality differences and some of these other things that where we can have these kind of variances. The imagery is it's so tied to perception that it makes sense to people.
Absolutely.
But let's start here with some of the questions. So if you have any others, please feel free to drop them in the chat there. Okay, David asked, do you mean people ignore stimuli on one side of their imagination or one side of their brain?
So one side of their imagination for imaginal neglect. And this comes from a stroke actually in the opposite side of their brain. Usually the stroke is in the right hemisphere, and these patients neglect information on the left part of space or of their mental images.
Is it, as someone who's never visualized, I only have ideas about what it might be like to visualize. Is it, I hear many comments about like, oh, it could be like a computer screen or a TV in the mind. Is that a fair representation of what visualization is like, or does it not really track?
I don't think so. Actually, yeah, the computer screen was the metaphor used by Stephen Kostlin when he put forward around the 90s his pictorial theory of visual mental imagery. But it was based on this idea that it is the primary visual cortex, which is the screen where images are projected. But we know this is not true. Even if you will find this theory again and again in the literature. No, I don't think it's a kind of analogic screen where images are projected. There are regions which we call high-level visual regions. We don't know exactly what high-level means here, but it basically should mean closer to semantic knowledge than the early visual areas. So closer to the knowledge we have of the world, which may make an interface between early vision and the knowledge we have of the world, which allows us to identify the object. So to see these glasses, to identify them, I see them, but to identify them, I must put the shape I see in contact with my knowledge of the shape of the glasses. And this is probably what these high-level visual regions do.
And it's, if I understand correct, it's not that for example, when someone is remembering something, revisualizing a memory or something that they've seen in the past, it's not like a video recorder and they're replaying exactly what they saw. It's generated at the time of experience.
This is very important. It's not a replay or as you said, of a recording. It's actually a rebuilding of the experience, and this has lots of implication, even in trials. I mean, when you have people describing what they saw, unfortunately, it's very rarely it's an accurate description, because we always rebuild our experiences of the past. It's not a photo, it's not a movie.
Exactly. And, I've read very interesting cases about this where maybe you can implant a new idea or a new image into that replaying. The further away you get from the event, the more that image kind of replays. And I think because people don't understand that it's not a video recorder,
exactly.
It can often be, they can be tricked maybe, or I don't know what the right word is, but
no, you're
maybe have too much confidence.
Right. And yeah, this came out when DNA testing was started. People saw that many people were accused, they were considered as guilty on the basis of witnesses, and this was simply false. This had never happened, and people started to realize this when technology made DNA testing, for example, available.
So fascinating, and I think really important for the aphantasic listening, because this was one of even my misconceptions. And you see it depicted in movies and TVs as people with photographic memory and re-experiencing. It's not necessarily a replay like that. We have some more questions. Let's try and get here. Paulina says, question re causes of aphantasia. Do you think early childhood trauma may cause aphantasia? How can we say for sure what the congenital is?
So no, well, yeah, unfortunately, we don't know. We don't know absolutely. What I can say is that there is some literature on adult onset aphantasia, which is not of neurological origin, which is not, at least where no brain damage can be seen with our methods, which can be perhaps not perfect. But anyway, there are several cases described in psychiatric situations. So in cases of depression, of psychic trauma in the adults. I don't know about kids at all. There are some descriptions of cases of people losing their visual mental imagery after, psychic trauma or depression or depersonalization, or a whole series of psychiatric situations.
So we know that in adults that trauma can lead to aphantasia, separate from brain injury or lesions. But we haven't actually studied it in children.
Not as far as I know, at least.
Yeah. Great question there, Paulina. Thank you for that. Okay, Lee is asking, I'm a hypnotherapist and I had a subject with aphantasia who remembered during a regression when she blocked visualization because she was overwhelmed and scared. So
yeah, this is theoretically possible, yes. Yeah. There have been descriptions like that.
Interesting. Okay, another one from Paulina here. In the neurological population with people who lose some mental imagery, have you had cases of people who have regained it partially or fully?
Not as far as I know. These cases, once again, they are quite rare and difficult to study. So, at least in my experience, the only patient I studied with this deficit of acquired deficit of imagery of words and letters, no, he didn't actually recover. But my experience is limited, fortunately.
Well, that brings us to the next question here from Jenny. Do you think it's possible to modify the imagery experience? So, turn on or turn off that imagery. We know it's a spectrum, could it theoretically be modified?
I mean, if we, once again, theoretically, yes. Empirically, I don't know of any such experiments. As for voluntary control of imagery, well, this is a very intriguing question, and I don't have a ready answer. We could imagine some experiments, because it is, in a sense, what we try to study is voluntary imagery. And indeed, it should be, by definition, what philosophers call cognitively penetrable, in the sense that you should be able to influence voluntarily your visual mental imagery. This should be the main difference with perception. You cannot unsee something you are seeing, or in other ways, you have very limited control of what you see. But in principle, you should have control. You can manipulate, you can rotate, you can manipulate visual mental images. So there should be some control, voluntary control available for visual mental imagery. Yes.
And that's for the voluntary side. Jenny asks another question here about the involuntary aspect of visual mental imagery, because we do know that people having these involuntary experiences, involuntary flashes. Do we know if there are differences that are happening in the brain that drive either the involuntary aspect of imagery?
I'm trying to think about that. I don't know whether there is evidence, but there could be indeed differences. So we know that for voluntary imagery, most probably they start in the prefrontal cortex, in the most anterior part of the brain. According to most people, voluntary imagery starts there and then propagates in the other regions of the brain. Maybe in involuntary imagery, the process is different. It could start, for example, I'm just speculating, from the parietal lobe, for the more posterior parts of the brain. But once again, I'm not aware of any specific study about that, but it's a very, very interesting question. Something I can say is about hallucinations. So not exactly visual mental imagery, but a kind of experience which doesn't come from the external environment as visual mental imagery. In some cases, there is the so-called Charles-Bonnet syndrome, where patients progressively losing vision, for example, because of retinal problems, they start seeing, hallucinate actually, seeing things, and they are quite aware of the fact that they are not real things. And in these cases, it has been shown that in this case, there is some activity in primary visual cortex, which is the afferented. It doesn't receive anymore the normal input from the visual system, because the retinas are not functioning properly. And in this case, you can have this release activity in V1, in primary visual cortex, which then progresses much like normal perception towards more anterior areas. And you can have, in this case, hallucinations, which are involuntary forms of visual mental imagery.
Interesting. So we do, in these hallucination cases, we see that there is a difference. And
Yes.
And we do know that I've had personal conversations with individuals. For example, what I'm trying to say is that the involuntary aspect of mental imagery, I think, is one of the more surprising things to aphantasics. The fact that it's not just a computer screen with a mouse that you can kind of control, is that it is possible to experience images that you don't necessarily choose to see. And I believe, just from some of the conversations I've had, for example, with first responders and from people who are in high stress situations, and then they get home and they can't unsee it, is what they say. These images are stuck in their mind. They can't get rid of them.
Intrusive imagery.
Intrusive imagery. So do we know why this occurs, or how this occurs differently from the voluntary imagery?
So, well, I keep going back to neurological cases because I'm a neurologist. And there is lots of evidence published many years ago, in the 1950s, by Wilder Penfield, the great neurosurgeon, who used to to directly stimulate the brain of patients with intractable epilepsy in order to know where if he was allowed or not to excise, surgically excise the part of the brain where epilepsy started. And what he had such an extensive sample of more than hundreds of cases, actually. And something which he saw is that stimulating the right hemisphere, especially the temporal lobe in the right hemisphere, was way more likely to induce hallucinations or what he called experiential responses. Patients said that, yes, now I can see familiar plays, or I can hear a song which I know very well, or I can hear friends talking to me. And this especially happened, not exclusively, but especially happened when stimulating the right hemisphere. Whereas for voluntary visual mental imagery, all the evidence, neuroimaging and patient neurological evidence from neurological patients points rather to the left hemisphere, especially the left temporal lobe. So there is, and Changhao Liu, my student, he reviewed the literature about this, and apparently it's quite consistent. More voluntary imagery seems to start from the left hemisphere, rather involuntary imagery, hallucinations and things like that, could start more on the right hemisphere of the brain.
Interesting. And these could theoretically be out of balance, or maybe someone experiences more of one than the other.
Theoretically,
which
yes,
is another one of these.
But we don't. I'm afraid we don't have direct evidence about that.
Very, very interesting nonetheless. We have quite a few more questions here, so we'll try and move through them. Tom Nichols asks, have you studied the changes in connectivity between brain areas during different states, such as dreaming, hypnagogic, drug-induced visuals?
Not for drugs, but for the hypnagogic state. This is a project we have right now. There is a team studying dreams and hypnagogic states here in the Paris Brain Institute, the so-called Dream Team, and we are we are setting up a project with them in order to study the relationship between our awake visual mental imagery networks and their networks during the hypnagogic phase.
Very interesting, because this is another one of those differences that I hear about. For example, for me, I don't, consciously, at least I'm not consciously aware of visuals in my dreams. However, there are other aphantasics who say, absolutely, I visualize when I dream, and when I wake up, I can't replay them, but I know that I was dreaming. So very, very much looking forward to
this is actually a common case. There has been a study by Thomas Andrion, who's now here, but a study he made in who's one of the Dream team members, and he did that in Australia with Joel Pearson about dreaming. He just asked people with or without aphantasia to speak about their dreams, and actually most aphantasic individuals, they do say that they dream. So aphantasia seems to be a deficit of restricted to voluntary mental imagery. It is true that the vividness of dreaming was rated slightly less in the aphantasic population than in the typical imagery population. So
that's a very interesting work going on here. Okay, we have Anna who says, I don't visualize, but I have some things that is related to what I see. I wonder if people who have the ability to visualize also have such an aspect of memories, but can't separate that from the visualization.
Well, typically we say that there are, so the visualization strategy that we can use, for example, to solve a geometrical problem, but you can solve the same problem by using non-visual strategies. so using arithmetics, for example. And yeah, from my personal experience is that, at least for me, the visual imagery is much easier than the arithmetic way. But I can understand that there are at least these two possibilities: the pictorial possibility and the propositional possibility.
Propositional one, yeah, exactly. Okay, let's. Scott says there's a lot of hype around artificial intelligence, but does AI offer a metaphor for how people reconstruct memories or images? Could that be extended to help explain aphantasia? I'm not sure how familiar you are with artificial intelligence, but
no, not much. I know that these agents or pseudo agents can make pictures based on verbal descriptions, exactly as we think typical images do, but I have no idea whether the mechanisms are the same or different. Or no idea. My bet would be that they are not the same processes, but I don't know.
What at least is very interesting, and I sent an email about the members here probably got the email a few weeks ago about if you ask ChatGPT to visualize a horse, to imagine a horse, it actually describes it. It says, "Oh, I can't imagine a horse the same way humans do, but I know lots of facts and scenarios about horses, and I can link them to all the different contexts." And it sounded very familiar. It sounded very much like the way an aphantasic would describe, knowing a horse.
Actually, we asked some of our questions to ChatGPT, and it was able to answer most of them. So the color, cherries and strawberries, it knew, probably because it encountered it in the massive training text.
Exactly. Yeah.
Text it was given. One thing it could not do is the shape of letters, for reasons I don't know, but shape of letters or words, it couldn't answer the questions. I don't know why.
Interesting. Well, okay, we have another one here. Have we been able to measure any metabolic differences of those with aphantasia and hyperphantasia when trying to respond to questions related to the ability to visualize or do spatial rotation?
Metabolic differences, not that I am aware of. No, I would be surprised to. No, I don't think so. Honestly.
I don't think so. I guess that's getting at are there energy differences, efficiency differences, and visualization?
Yeah, the point of the question is, it is a good point to see whether a strategy could be more energy efficient than another. But no, I don't think anybody has done that.
Okay, we have another one here from Tom. Given neuroplasticity, do you think that feedback from EEGs using sound or VR could improve visual imagery or connectivity?
Yes, this is what we were discussing before with Tom. Why not? I would like to try one day to use neurofeedback to see whether the subjective experience can change perhaps in aphantasic individuals by using neurofeedback. Why not? Yes.
Sign me up. I'll give it a shot. Monica here says, what are future prospects for research into psychedelics and aphantasia? Do you have any insights about how to go about collecting baseline visualization data in a population on a larger scale? So there's two questions here.
Yes. So baseline visualization, there are a few studies right now in the literature that they did that on a rather large samples of people. Psychedelics, I don't know, there are already so many legal limitations to our research without using psychedelics. I can't even think of asking an ethical approval for a study using psychedelics. Not in France, at least.
Yeah.
Not ready to
very difficult to do that kind of work. Very difficult. Okay, we have another one here. Paolo, could you describe how this experience occurs? In my awakening phase, the hallucinatory phase of sleep, I have vivid images, snapshots. If I close my eyes immediately, the snap is gone. So,
yeah, there are two types of hallucinations. You can have related to sleep. Actually, 3 types at least. There is dreaming, of course, typical dreaming, but then there are hypnagogic hallucinations when you fell asleep, and hypnopompic hallucinations when you wake up. So these are well described. I don't know what happens if you close your eyes, or the eye closure thing. I'm not able to answer to, but it is well known that in these phases of sleep, preliminary and the end of sleep, we can have hallucinations. Absolutely.
Yeah, very, very interesting. And then you have that semi-conscious kind of state, so you might be more aware of it. And as you arise from that consciousness, then you
yes, and this
get
lucid dreaming, when you are aware of being dreaming, which is even more fascinating. It doesn't happen, but it has been studied a lot here at the Paris Brain Institute. Yes.
Lots of great questions. I think that's the end of it. We have a couple of comments. I too see very clear images in my dreams. I can see images in my dreams, but I can't remember or recreate them. So it does seem like this is a common experience among the aphantasics. Well, we're at the end here of the discussion. Paolo, it's been really great. Thank you so much for your time and for a lot of very interesting points. Lots of great work being done and lots of unanswered questions that hopefully aphantasia can help illuminate regarding consciousness, everything from consciousness.
We'll keep in touch, Tom,
visual imagery.
About this.
Absolutely, we'll keep in touch, and we'll have you again at some point in the future as the research evolves.
Thank you very much.
Thank you very much. Bye, everybody.
Bye-bye.